Hello, we're going to start today's session with a scientific inquiry. You'll remember a scientific inquiry is where we set our student a question to investigate scientifically, and then we make observations and compare and discuss those observations and come up with some conclusions. We're then going to compare the scientific inquiry with a historical inquiry. So what are the similarities and differences between working in science or as a scientist and working in history as a historian? Let's start with the scientific inquiry. This one's going to be an investigation of grip and slip, and so it's going to tell us something about the factors that affect whether or not two surfaces rub past each other, or friction. For this you'll need a ramp, and to make the ramp I've just folded a cereal packet in half. You can stick yours. I'm actually just going to use a bulldog clip and clip this one even quicker. And now we've got one surface, and you can see that by tipping this up I can increase the chance that my objects will slip. I've chosen the objects that I'm going to test strategically because I already have some ideas about what some of the factors are that's going to make a difference. So let's have a look at the first one. And I chose this because it's got a really nice smooth base, and I think that means it's going to be particularly good at slipping. So let's start it here and just tip it up. There you go. We didn't need to tip that very much at all, did we? Next one, well, I can reuse some of the items I had last time, so actually here comes my bottle top again. Now, this also has quite a smooth base, so I don't think this one's going to need much either. There we go, it's sort of slipping around there, isn't it? All right, so let's see if we can have something to compare with those. So here's a button, and what's interesting about this button is that it's got two surfaces because it's got fabric on this side, and that's quite rough, and then on this side it's smooth and metal. So I predict there should be a difference depending on which way up I put the button. So let's start with it on the grippy side. This is the one I think is going to be better at gripping, and oh, just about there, it's starting to move. In fact, yep, just about there. So now let's try and keep that about the same and turn it over and see what happens. Oh yes, really very quickly. Now, interestingly, with my button, I actually have two of these buttons, so I can compare both surfaces at the same time. So I'll put one way up and one this way up, and then start to tip. There we go. That's pretty impressive, isn't it? Oh, and finally it goes. Took a bit of hunting, but I finally found. Okay, this is the next one I've come up with. This is a ball. I'm going to reject this because it will roll and not grip or slip. One more. This took a bit of hunting, and I managed to find one of these, chosen strategically because I predict that this will be the best of all at gripping. That's because it has quite a large surface, which I think is a factor, and it also has a very rough surface, which I also think is a factor. So let's just see how much we can tip that up. Doing well. There we go. I reckon that was probably the most of all. Now you'll remember how important it is in science to repeat and to make many observations. So I won't just do this once, I'll do this a few times, and each of my objects a few times. Also in science, when we can, we like to be as accurate as possible with our observations. So you could measure the height of your ramp by putting a ruler to the top surface of the ramp as you tip it up, and that will give you an indication of just how steep your ramp is.